Hello, good morning, everybody, and welcome to Mechanics One. My name is Chana Suarez, and I will be a lecturer facilitator for the course. What I have before me here is my email address and a WhatsApp number where you can send me messages by either method. But if you want a quicker turnaround, it would be better if you send me a WhatsApp message, then I can respond to you more quickly. I've been here at Michael for about 22 years. After finishing my master's degree, I came here shortly after that. A few years after that, I have a master's degree in mathematics. With my thesis was in algebra. I wrote about an area called Galois theory. You probably can look that up. Galois. Very interesting man. He died in a duel at the age of 21, but before that, he did a lot of mathematics, especially with the solution equations. So, after completing that, a few years later, I came to Michael after spending some time in a secondary school. So, I taught in a secondary school for a little while before I came to Michael. And I've been here since about 2002, so maybe 22, 23 years since I've been here. And I've been teaching mechanics for quite a while as well. In fact, I actually like the mechanics because my first degree was in physics and mathematics, so I have a little bit of physics background. So I see the mechanics as one of the best marriages are the physics and the mathematics. You can, I think the mathematics is the best language to express a lot of the concepts in physics, and mechanics is a prime example. So I've been doing this a little bit long, teaching the mechanics one in various forms. Previously, before we had a degree, we worked with what they call the joint board. So the syllabus was a bit different, but essentially the same content. So familiar with the mechanics in all the different iterations. And it's really an interesting course. If you interested in the physical world, then this is a good course for you to do. Now, what is this mechanics thing here all about? Well, as you might imagine, mechanics deals with motion, right? Some kind of movement. So that is the essential thing that we'll study is motion. But not only that, within motion, we have to grapple with the ideas of equilibrium as well. So, equilibrium would imply that the object is motionless. That's possible. But that would be what we call static equilibrium. But you can also have equilibrium with a moving body. That's what we call dynamic equilibrium. So essentially, that's what we'll be doing, studying motion and equilibrium. Another concept that we need would be a very important one is the concept of a force. Now, normally they define a force as a push or a pull. So these forces, these produce the equilibrium and produce the motion, which we'll be studying. So we need to be able to identify forces, the different kinds of forces. So essentially, that's what we'll be studying, motion and equilibrium. And underpinning all of these will be what we call Newton's laws of motion. This would be what we call classical mechanics. Now you have two different types of mechanics now. The classical one was developed about 400 years ago by people like Newton and Galileo and some more people. So we can also call that the macroscopic mechanics, things that we can see. And about 100 years ago, after the discovery of the atom and electrons and protons and things like that, a new type of mechanics developed, quantum mechanics. So this one here we can call it the microscopic mechanics. So people like Einstein, Max Planck, Schrödinger, Dirac, Fermi, people like these. Some of these people were instrumental in the construction of the atomic bomb that the US dropped on Hiroshima and Nagasaki. And you have a whole microscopic level mechanics there, things that we cannot see. And they refer to that as quantum mechanics. So if you continue and study more physics, and there's a lot of mathematics in it as well, then you might be exposed to this. So this is, in summary, what we just spoke about, what mechanics is all about. So it's really a branch of mathematics or physics that deals with bodies in motion and bodies in equilibrium. And central to the study, as we said, would be the Newton's three laws, Newton's laws of motion. So over the next 15 weeks, this is what we'll be having a look at and exploring and see if we can solve some real world problems that deal with mechanics or deal with motion and equilibrium. So this is what we're trying to achieve at the end of this course here. To develop models to analyze physical problems and to apply the concepts that we learn here to solve real world problems involving, as I said, motion and equilibrium, and also to use the language of mechanics accurately, to call things by them correct names and to write coherently so that others can read it. So the overview of the course, this would be, the course is divided in 3 units. So unit 1 will start off with motion in a straight line. So we're going to look on the graphs of motion, which some of them you should have been exposed to already at the CSEC level. Most likely distance time graphs and speed time graphs and how you extract information from these graphs. So we look on these as well, and velocity time graphs and displacement time graphs. After that, we can use these graphs and derive some equations for the motion with constant acceleration. So remember, acceleration is the rate of change of your speed, how fast you speed up. So the only problems we'll be looking on here is where the acceleration is constant, like motion under gravity. So if we throw a ball in the air, the acceleration will always be constant at approximately 10 meters per square second. So as long as it's not too far above the surface of the earth, because the gravitational attraction, it diminish the further we away from earth. So like on the moon, the gravitational attraction might be about 1/6 of what's on earth. So people might float around in space. If you usually see that when people traveling in outer space. But we just use constant acceleration. So work out the equations of motion, and use them. The next unit will be Newton's laws of motion, where once again the idea of forces is central to this. So we learn how to mark forces, to recognize them, and to represent them differently, especially with the use of represent them algebraically using vectors, which you should have done before, where it can break up a vector in two dimension as a unit vector, in terms of unit vectors. So like 3i plus 4j, things like that. And Newton's laws, there are three of them. Most people are familiar with the third one, which says that to every action there's a equal and opposite reaction. A lot of people like to use that one. But the first one is essentially the law of inertia. So what that really says is that an object resists changes to their state of motion. So an object at rest tends to stay at rest unless you apply some force. And a moving object stays moving unless you apply some force. So the object at all times trying to maintain the state that it is in. Then we look at some momentum, which again is another what we call a vector quantity, so it would have some direction, which is actually the mass of the object times its velocity. And we look on something we call the conservation of momentum under ideal circumstances. So we look at that. Right? So that would be unit 2. And unit 3 concerns power and energy. Work, power, and energy. So this would be like the work done by say an engine that is moving a vehicle, and the power provided by the engine of the vehicle. And the final thing we look on is some mechanical energy. And we have two different types of energy we'll be looking on. The energy by virtue of motion, which we call the kinetic energy. And the second one is energy by virtue of position. So that's what we call potential energy. So we try and complete as much as we can over the semester. And then the assessment, well, it's a 60-40 course, meaning 60 final exam and 40 coursework. So we do a couple tests, two tests, were 30%, and a project or a presentation, most likely it's a presentation, worth 10%. And the final exam will be worth 60%. So in a nutshell, that's what the course is about. So welcome again. We hope you enjoy yourself. I can't speak for myself. I usually find great enjoyment in solving challenging questions. Not everybody feel the same way, but from I was a student, that's how I felt until now. I have a sense of accomplishment. So what I'm trying to say here is try the more challenging questions that provide greater satisfaction, and plus you learn more. And if you're a sportsman and you want to improve your game, what you need to do, you have to play against stronger opponents. If you continue to play with the weak opponents, your game will improve. So in this case, the stronger opponent would be the more difficult questions. And that's how we improve our game, our mathematical game. So have fun. And remember, you can contact me anytime with any questions that you might have. All right? All right. I'll catch you in class shortly. Bye.